now. This is called the final three. So what I'm doing is I'm working my way through the last three questions of each exam paper since June 2017. This is June 2017 paper 3. If you want to check out my channel, The Maths Jedi, you'll see I've got other papers on there, including paper 1 and paper 2, and I'll be adding these all the next few days and weeks. So if you're revising for your June exams and you're coming up to the final stages of your revision, just do check those out, because that will really help you out a lot in terms of your preparation. And if you could leave a like and subscribe to my channel, that would really help me out a lot. So here we are, paper 3, June 2017. This is the third to last question, question 18. And so what we've got here is a situation where they're asking you about circles and tangents. So they're saying that A, B and C are points on a circle, and the circle is centered O, and DA and DC are tangents to the circle. DO is 9. I haven't filled that in for you, so I will just put that in there to make sure that I've reminded myself that's 9. And it's asking you to work out the length of this all the way around, the arc length. So you should remember the arc length from remembering through your revision, that arc length is the angle in the center divided by 360 times 2 pi r. So that's the arc length. The sector area is theta over 360 times pi r squared, in case you ever asked that question. But for today we're asked about arc length, so that's what we're going to be working on, is theta over 360 times 2 pi r. Now, r in this case is 5, so we've got to remember that. What would be helpful for me is to work out this angle then, this angle all the way around the outside. So what's the strategy? The strategy's got to be that we start by working out the angle in there, because if we can work out the angle in there, we can double that to work out the whole thing, and then take that away from 360 to get this section here. So how do I work out the angle in there? Well, we've got a couple of things about tangents that we know. We know that tangents are at right angles to the radius, so I've put a right angled in there. And then we've got a right angle triangle, ODA, where 9 is the hypotenuse because it's opposite to the right angle. And if we're looking at this angle particularly, this 5 must be the adjacent. That's the adjacent, that's the hypotenuse, there's the angle I want. So we know that this is going to be a cosine problem. So cosine of this angle, let's call it theta. Cosine of theta equals adjacent over hypotenuse 5/9. So theta equals the inverse cosine of 5/9. Okay, and again we can use our calculator, because this is a calculator paper. So we're going to do the inverse cosine of 5/9. So here am I doing that on my calculator. So inverse cosine of 5/9, and just working that out, and I get this number 56.2510, etc. So we're going to write that down, 56.2510114. So I've just written it down there. I'm going to double that because I want the angle in the center, this whole thing here. So my whole angle in the center there at the angle AOC, the interior angle there, the smaller one, is 112.5. And then I'm going to take that away from 360 to work this angle around the outside. So I'll work out my angle AOC. So I'm going to do 360, take away that, and it's 247.49. So 247.49, 79772. Just show you that there. So that's 247.49. So the angle I need is now 247. I've got the relationship that I need, so we're going to do 247.4979772 divided by 360 times 2 times pi times the radius, which is 5, and then put that into the calculator to work out my answer. So I've still got 247 there from earlier. So I'm going to divide by 360. So I'm just going to show you that there. I'm going to times that by 2, times that by pi, times that by 5. So, and then that will give me my answer. And I want it to 3 significant figures, so 21.6 to 3 significant figures, and that's in centimetres, because all my other mentions have been in centimetres, so 21.6 centimetres. Okay, moving on. The second to last question is a inequalities question. You would have dealt with inequalities several times before. It's the second last question. It's worth 3 marks, so not many marks, but completely doable really. When you get a quadratic inequality, the thing to do is just for the moment, just treat it like it's a normal quadratic. So we're going to try and factorise this if we can. So we're going to solve this again, coefficient of x squared. So if you see my other videos, you'll see me going through this. So I'm going to do 2 times minus 2, which is minus 4. And I'm going to look at factors of minus 4 that make 3. So 4 minus 1 is the pair that I need. And again, I'm going to pair these values off. So I'm going to have 2x squared, which stays the same from the beginning. I'm going to write plus 4x, because I know that's in the 2 family. And then I've got minus 1x, and then minus 2. And then I'm going to solve that. So I'm going to factorise this. So I'm going to take out what's common from these first 2 factors. So I've got x plus 2. And then I'm taking out minus 1. And again, that's x plus 2. And again, so my factors must be 2x minus 1, x plus 2. Now that would be a simple quadratic factorisation, but of course this is an inequality. So what does that mean for my inequality? Well, if I sketch this graph, the graph of this, I've got 2 roots, half, positive half, and minus 2. So I'm going to sketch that in here. So minus 2, positive half. I know it's a happy graph because it's got a coefficient of x squared as positive, and I know it cuts the y-axis at minus 2. So it's going to look something like this. Okay, just going to draw it up. That's going to be minus 2 down there. Okay, so where is my graph? Where is my graph more than 0? Where is it more than 0? So it's more than 0, everything to the right of a half, so x is more than a half, and everything to the left of minus 2, that's where it's more than 0. So everything to the left of minus 2. So it's those 2 regions that I want. X is more than a half, and x is less than minus 2. Relatively straightforward, some revision stuff to pick up on. Just make sure you know how to handle your quadratic drawing, and then you're fine. 3 marks, not a problem. The last question, again, not that difficult really. The first one, really quite simple. It's an exponential curve. All exponential curves go something like this, so just in case you don't know, and they all go through the same point. They go through 0, 1. It's asking for the coordinates of A, so 0, 1. They all go through that point. In terms of the second part, the equation of a circle again, so they're quite fond of circles, it seems to me, in this particular paper. So I'm going to draw a quick diagram here. So this is 4 minus 4, and then 4 minus 4. And then again, we've got circle C is translated by the vector 3, 0. So that's 3 to the right, nothing at all up. Draw a sketch of circle B. So this is what it was before. If we're moving everything 3 places to the right, how would it look? Well, instead of having a centre at 0, my new centre would be 3. And instead of having a cut at a root at 4, it would cut at 7. And instead of having a root at minus 4, it would cut at minus 1. And then again, it would still peak at 4 and minus 4. So 4 and minus 4, those 2 values there. But it would be a circle that looks something like that. Okay, so, and it would look something like this, but the centre would be 3, 0, and it asks you to state that. So it says list the coordinates centre of circle B. So my centre is 3, 0, and any points of intersection with the x-axis, well, I've got them, minus 1 and 7. So again, relatively straightforward, not a problem, quite a simple problem to do. That brings us to the end of this video. Keep an eye on my channel. I'll be adding 2018 papers the next few days, and 2017 November, 2018 June, 2018 November, next few days and weeks. I do wish you all the best of luck for your exams in the summer. That's all for now. Goodbye.